right, well, good afternoon, everybody. It's 1 o'clock Eastern time, so we will go ahead and get started with the intro to the presentation. Then we'll get started with the presentation, and then the demo will follow shortly after. My name is Tyler Newberry. I'll be the host and moderator for the event today. I'm the Marketing Programs Manager for the StorTrends Channel Products team here at American Megatrends. With me today is our Director of Sales and Marketing, Justin Bagby, as well as Senior Solutions Engineer, George Rodriguez. Those guys will be along in just a few moments to get started with the presentation. But before we got started with all that good stuff, just want to go over a few quick housekeeping items before we get rolling here. Number one, with regards to the pizza delivery, this is a virtual lunch and learn. So the lunch part of that, obviously with regards to pizza, your pizza should be arriving right about now if it has not already. Sometimes the delivery person can run just a few minutes behind, so be sure to let us know if your pizza has not arrived by the 1:10, 1:15 Eastern time frame, because that typically means that something's wrong and the delivery person's not just running a few minutes late. If your pizza does arrive after that, or hasn't arrived by then, I should say, feel free to just shoot me over a quick email. I've listed that in your chat screen. It's just tylern@ami.com, and just let me know a quick email. Hey, pizza's not here yet. What's going on? And we'll get that sorted out. One quick note for folks on the West Coast, California, Oregon, Washington, Nevada, your pizzas will be arriving at 11 a.m. local time. That's because your pizza restaurants are actually not open yet, as it's 10 a.m. there. So just a little bit of information there. Second, with regards to making this as much of an interactive event as possible, that's exactly what we strive to do. So with that, feel free to shoot over any questions that you have via the Q&A communicator located at the bottom right-hand corner of your screen, and we'll either answer your question live on air or shoot you a quick note back if it makes sense to do so in the communicator. And for anybody that we don't get to, we'll try to make sure we contact you after the event and get your questions answered for you. The third and kind of final thing is with regards to technical difficulties. We are kind of maxing out the event today for WebEx. We had a huge registration for this event, which is terrific. It's exactly what we wanted. However, WebEx is not always super cooperative when we have huge numbers on there. So if we experience any technical difficulties, like the audio becoming grainy or the screen resolution not being great, just please be patient. Usually these types of issues resolve themselves within just a few seconds, but just want to make you aware that they can certainly occur, especially with a load on the system like we have today. But that is about it for all the boring stuff. So I know you guys are here for the presentation and for the pizza, so I will go ahead and turn it over to Justin for part one of the presentation today.
All right. Thank you, Tyler. Greatly appreciate the introduction there. As Tyler indicated, if you guys and gals have questions, feel free to throw them into the chat. We've already received about 40 questions during the registration period, and we've sorted through a lot of those, and we've tried to prioritize them and put the most that pertain to NVMe up at the top. But if you have questions, feel free to shoot them over. We've got a team of individuals here that are watching the chat, and they can answer your questions as they come in. If you want to follow up with us after the event and take the questions offline, that's perfectly acceptable as well. Just feel free to get in touch with Tyler, and he'll put you in touch with the solutions engineer, and they'll be able to answer any of the questions that you have about NVMe, all flash, or anything that we're going to talk about in the presentation today. All right, so let's get started here. Title of the Educational Virtual Lunch and Learn today is NVMe is a Game Changer. So when we sent this out, a lot of you registered. As Tyler said, we had a max number of registrants for the event. You guys were prompted with a question of how much you know about NVMe in the registration process. About 10% of you answered that you know a lot about NVMe. About 70% said that you know a little bit about NVMe. And then the remaining said you don't know anything about NVMe. So this presentation has been geared towards the vast majority of you that know a little bit about NVMe. We're going to go through a lot of the high-level NVMe technology options and the specifications today. We're going to move that into the primary data storage options. We're going to talk about where you can store your data, the options that you have with NVMe. We're going to spend a couple slides on NVMe storage arrays. We're going to talk about a SAN specifically. And then we'll talk a little bit about an NVMe JBOF, which stands for just a bunch of flash. We'll go through the details associated with that. And then we'll talk a little bit about StorTrends iData. We're going to do a live storage array demo for you, and then we'll do a live Q&A session. So we've got a lot to cover in a 1-hour period. Again, if you have questions, feel free to shoot those over in the chat. I see some questions coming over now. The team here is jumping on those. So just keep those questions coming. If they're really good ones, we're going to absolutely try our best to get to all of them, but if we can't, we'll get to the good ones. So send us some good questions. All right, here we go. Just a quick introduction to American Megatrends Incorporated. A lot of the industry knows this as AMI. There's about an 85% chance if you reboot the computer that you're watching this presentation on today, you'll see the AMI logo, the little triangle logo, and the American Megatrends name will show up when it reboots. That's because we're the predominant system BIOS that's on that computer. So just to jog your memory before we get started there, that's a little bit about AMI. We've got some slides that we'll get into about some of the products that we offer. We were founded in 1985 in Atlanta, Georgia. We have 12 international offices. We have a worldwide presence, a global footprint of about 1,400 employees, and about 85% of our employees contribute to an engineering fashion, meaning they're development engineers, support engineers within the organization. Worldwide recognition, AMI products are shipped in more of half of the computers that are shipped worldwide today. So if you look at a Gartner report and you look at the number of PCs, specifically x86 and non-x86, we're in more than 50% of those. One of the things our marketing group likes to say is over 1 billion motherboards have been served. So kind of like McDonald's, except we feed the motherboards with the system BIOS. Innovative IP, AMI is known for its innovative IP. We have over 400 IP patents that we've brought to the table. Our focus is primarily on BIOS, server, storage, and data center technologies. So we'll move into the next slide, and hopefully some of these slides here will kind of jog your memory, and you'll know where you've crossed paths with us before from a product perspective. First and foremost is the AMI BIOS. This is what most of you know from AMI. We started in 1985 as a BIOS company. We're the #1 BIOS company in the world today. The current BIOS product name is called Aptio, so if you reboot a server or a storage array in your data center today, you're most likely going to see the Aptio and that American Megatrends logo like you see there in that black box in the bottom. The AMI BIOS and Aptio shipped on millions of computers every year. We're found in servers, storage arrays, desktops, embedded systems, thin clients, notebooks, laptops. We even have a what we call a bootstrap BIOS that we sell that also ships on touch screens and tablets and such that are not x86 based. They could be Android based or ARM based. So we're in a lot of the different pieces of the technology that you touch in your data center and in your home. They all start and begin with AMI. When you press that power button, we boot that system up and enumerate all of the hardware devices on those boards. Something that you may not know us from, but we're there. If you walk into your data center this afternoon and you take a look at your racks and you see the blue lights and the green lights and the red lights, hopefully you're not seeing too many red lights. The first thing you're going to know is all of those lights, they look really good when the lights are off. It kind of looks kind of cool. Those are SGPIOs that we're sending from the backplane controller, from the backplane, to those the front bezels on the front of the board to the front bus. That's our backplane controllers. We're the #1 shipping Tier 1 controller from a backplane perspective. We're shipped on OEMs worldwide. So we push the SATA, SAS, and NVMe drive information to the front through those LED sensors. Another thing, if you walk into your data center this afternoon, let's say you're sitting at your desk, you don't want to go into the data center, but you want to remotely reach one of those servers or one of your storage arrays. You're using a product, some people call it KVM, others call it IPMI, some people just call it remote management. Those are all accurate. It's basically IPMI, KVM, and virtual USB tied together. AMI developed that technology back in 1997. It was a physical card at that time called a Megarack G card. Dell accepted that card in 1997 and appropriately renamed it the DRAC card. It stands for the Dell Remote Access Controller. So if you go pick a storage array or a server that's in your data center today, you're going to find the Megarack technology sitting in that server that's handling all of that remote technology capability so that you can remotely manage that server. Today, it's not a card that sits in the server. It's a software that we license to these OEMs, and then they put that down on the board in a flash, and then it goes and it's operated by a system on a chip known as a SOC. which is a outside CPU that sits outside of the x86 technology, and that's so that you can manage that server or storage array in the event that it goes down. It's a secondary board, basically. It's a secondary device controller that sits inside of your servers and your storage that allows you to reach that device even if it's in the weeds. Another product that you've probably used, and you may have not have put two and two together that it's AMI, is the MegaRAID controller. So if you walk into your data center this afternoon and you touch an HP box or a Dell server, or you pick your flavor of the server, if you open up the count on the box, you're going to find that there's a MegaRAID controller most likely down on that motherboard. Back in 1994, we developed the MegaRAID card. Again, this is a PCIe-based card. It was a PCI-based card back in 1994. We became the #1 RAID controller card manufacturer in the world in 1996, just 2 years later. Gartner recognized us as the leader in their Magic Quadrant. We sold this division to LSI Logic in 2001, which is now owned by Broadcom. Again, same thing as like the G cards. These RAID cards moved away from an actual plug-in card, and now it's ASIC that's soldered directly down on the board, so it's the controller that we made that's soldered down on the board. So if you go take a look at your servers, you're going to see a Broadcom / Avago / LSI Nitro MegaRAID chip that's down on the board that's doing your low-level RAID. So when you set the RAID up on these servers and you decide you want a RAID 1, a RAID 5, a RAID 10, a 50, a 60, or whatever it may be, all of that logic is based off of the MegaRAID functionality. All right, so now that we've walked down some of the products that you've came across with AMI, let's jump straight into NVMe, and let's talk a little bit about NVMe technology and the benefits, the advantages, the different points that it touches. We've got a multitude of slides in here, and we'll try to explain this the best that we can. It's a little confusing for a lot of people that don't understand maybe how the data flows, specifically from when the I/O comes in and what the CPU does with it and how it's routed to memory and down to the SSDs and back up. We'll try to slow all that down for you and just try to break it down. If you've got questions, feel free to throw them into chat, and we'll be glad to answer those. Again, you can send it just directly to us on an individual chat. So if you're uncomfortable about something and you've got a burning question, maybe you've got an acronym that you don't know, feel free to send it over. We'll be glad to answer it. All right, so NVMe technology overview. So first of all, what does NVMe stand for? There's a lot of acronyms in our, in our industry. Everything that we do, it's a requirement. You have to have an acronym for it. So NVMe stands for Non-Volatile Memory Express. Others call it NVM Express. It's NVMe. So as a vendor, we call it NVMe. Everyone that we have here at AMI would reference to it as NVMe. A lot of customers that call us asking for this, they're still calling it NVM Express, but it could be called any of these three. What is NVMe? So from the top level viewpoint, it's a protocol. It's a communication protocol that was developed by a consortium of vendors. There's over 100 vendors that touch the spec. They've designed this from the start to finish to work with Flash. That was built from the ground up to work with Flash and take advantage of the performance of Flash. So it was designed to transport the data over different interfaces, and it's optimized for NAND Flash. Now, the most common transport or common protocol that's used is PCIe. That stands for Peripheral Component Interconnect Express, again, another acronym. PCIe is a bus that sits on your motherboard and your servers that's directly connected to the CPU. That's the most common transport that's being used for NVMe. What does the NVMe protocol allow? It allows for high bandwidth and low latency for the storage. So it's the way that we get the data to the storage and from the storage at a rapid rate, and we reduce the latency to a very low level. We're talking microseconds. We're not talking milliseconds. We're not talking seconds. We're talking microseconds with NVMe. So it's going to address bandwidth, IOPS, and latency. And again, it was designed from the ground up, and it's optimized for Flash. So it's not a technology that was built pre-Flash that's trying to be adhered to Flash. It's not a Band-Aid technology. It's not a Band-Aid protocol. It was specifically designed for Flash. All right, so let's talk just a little bit about why is NVMe important. The first thing is legacy buses are slow, and they've become a bottleneck. And when we say legacy buses, we're specifically meaning SATA and SAS. So what SATA and SAS do is they move the data serially through one queue. So they were really good for hard drives, for HDDs. That's because the HDDs were spinning at such a slow RPM rate. Now, back 10 years ago, all of us thought, 12 years ago, 15,000 RPM drives were great. We wanted SAS, 15K RPM drives. Give me a 600 gig SAS, a whole tier of that, and I'm good to go, right? But it's really become the bottleneck these days, that SAS and SATA interface. Flash is inherently fast. It's insanely fast. But without NVMe, it's limited by this SAS and SATA protocol. So the bottleneck changes. If you notice, the pinch point changes every few years. Just a few years back, we were having discussions of networks, right? Everyone was on a 1G network. We all started talking about 10G. Everybody's saying you got to go to 10G. Everything needs to move to 10G. Well, networks slowly became the bottleneck, and then that pinch point changed, and it became a media bottleneck. The drives are the bottleneck. We came out with flash drives, so the media was resolved as the bottleneck. Now, flash has this ability to read and write at this great level. You can get to 1 million IOPS with the storage array now. But the interface has become the bottleneck now. So you can kind of see how the pinch point or the bottleneck changes from place to place. As we identify new technologies, a new bottleneck or a new pinch point presents itself. So what NVMe fixes first and foremost is the protocol. It's fixing that slow bottleneck that's there in the protocol. So how does it do it? NVMe moves the data in a parallel process with thousands of parallel queues. So I'm going to explain this in a couple slides here, and I've got some pictures and some images that'll kind of go through and help you understand how it's moving the data. But for you storage guys and gals that are on the call today, think about single-threaded versus multi-threaded as an analogy. With a single thread, you're only able to push so much data through that pipe. But with multi-threads, now we have multi-threads that can execute at the same time simultaneously or parallel that speed everything up. So it's basically multi-threading is kind of the way to look at it as a good analogy. Now, NVMe is a disruptive technology. And the reason that everyone's claiming it's a disruptive technology is because it's going to displace SAS and SATA SSDs. SAS and SATA SSDs won't go away. It's kind of like the tape versus spinning disk discussions when you hear people say tape's going to die by this certain year. It's never going to die while certain people are using it because it's going to live. People have become accustomed to it. It's part of their infrastructure. SAS and SATA will stay the same way. People are going to consume it. People that have bought all flash arrays and have invested a lot of money into SATA and SAS, they're not just going to throw those flash arrays away and go buy NVMe unless they have a specific performance gain out of it. They're not going to do that. It'll just continue to live, but they will eventually displace it. So if you read the analyst, if you go check out Gartner or any of the other big-time guys, they're going to tell you that by 2019, all of the SSDs that are shipped in servers and storage arrays will be NVMe-based. And that's probably predominantly true. And they're saying that SATA and SAS SSDs are going to be phased out. So let me break NVMe down a little bit further. Let's go one more step. There's two pieces to NVMe that I really want to make sure you understand and that we break apart here. First is the interface or the protocol. Second is the media, or in what we're going to call in today's presentation is SSD. So there's two pieces to this NVMe. So the first piece, let's talk about the interface and the protocol. This is NVM Express or NVMe. It's the I/O interface to the PCI SSDs. So NVMe over Fabrics is what a lot of people are working on. It's also known NVMe OOF. This enables the storage network of the NVMe. So when you start talking about the fabrics and running NVMe over Fabric, you start talking about RDMA over Ethernet, InfiniBand, Fiber Channel. There's a multitude of flavors there that are allowed for running NVMe over that fabric. But the most commonly known is going to be over the PCIe. That's what you're hearing most vendors talk about. That's what you're seeing at events. When you go to Open Compute, when you're going to the server memory flash summit, you're going to see everyone's talking about over PCIe. And we're going to get into this a little bit further. We're going to talk about JBOS and how they route over PCIe, and we'll spend some time on that. But NVMe removes the overhead and the limitations of the standard storage protocols. So what do I mean there? Well, specifically, if we're doing NVMe over PCIe, you're removing the iSCSI hop. You're removing the fiber channel hop. There's the standard storage protocols that choke down the performance. So NVMe is an interface allows the removal of that by extending the PCIe bridge from the CPU directly to the media. And I've got some slides that will explain this a little further if you're still a little fuzzy on it. I see a lot of questions coming in right now specifically asking about the differences in PCIe and InfiniBand and PCIe versus fiber channel. Let's get into that in just a few more slides, so hopefully we'll answer all these questions that are coming in. So the second component that I want to make sure you understand clearly is NVMe media. What is NVMe media? NVMe media is just where the data is stored. So think of it, it can be RAM, it can be your SSDs. Just think of it as the media where the data actually sits, right? All right. NVMe media comes in a multitude of different form factors. You're going to hear us talk about M.2, U.2, AIC, there's BGA. There's a lot of different form factors that it comes in, and we'll kind of slide into each one of these. So here's a picture that kind of explains the differences in the form factors. On the bottom left, you're going to see an NVMe U.2 form factor. This is just your standard SSD form factor. So for all of you that have already touched SSDs, you have them inside of your servers or your storage arrays, that's what it looks like. It's a 2.5-inch looking drive. It's a standard SSD. The middle section here, you're going to see a PCIe. This is a PCIe plug-in card. It's known as AIC. That's the form factor type. So you can see that's an Intel card that plugs directly into a PCIe bus. So this is to juice your server. So if you want to juice the server with NVMe, you would throw this into that PCIe slot. So maybe you're out of memory, maybe you're out of DIMMs, and you want to throw some more, NVMe. You want to throw some NVMe into your server to give it some splash, to give it some more power, some more juice. This is what you would get out of that function. This is the form factor used for that function. And on the right, you have NVMe M.2. This is a very specific form factor. This is used for a lot of contained or closed devices. There are storage vendors that are putting NVMe M.2 into their boxes. These are not hot pluggable, hot changeable typical devices. These are typically left in place, not used, not disturbed. So kind of think of it from that perspective. So on the far left, your U.2 would be hot pluggable in a server, a JBOD storage array. The middle PCIe AIC form factor plugs directly into a server, and then your NVMe M2 goes into some type of a self-contained closed unit typically. All right, so let's talk just a little bit about your traditional server architecture. So in the image on the left here, it's a very simplistic drawing, but just want to highlight kind of how it works. Most of you on the call probably really understand this well. In a typical environment, what's going to happen is you're going to have I.O. come in. The CPU is going to write it to the DRAM, so it's going to go directly to your memory that's sitting on the DDR bus. And then it's going to go down into the controller level, and it's going to write it to the HDD. It's either going to, it could be an SSD as well. It's going to be a SATA or a SAS interface that's sitting there. Now, that data is stored on that lower level media on that HDD or SSD, and then the CPU fetches that data from the HDD to move it back up to memory as it's needed. So that's kind of how your data moves around in a typical traditional server architecture. Now let's kind of explore what happens to that architecture with NVMe. So these are some NVMe options. Obviously, there's three different options in the image on the left, and you'll notice by the green bar that kind of moves up and down here, it explains the differences in those options from a latency perspective, from a cost perspective. So the closer you are to the CPU, the more it costs, but the higher the performance. So you can see the first option here is on the DDR bus, there's an NVDIMM that's sitting there. That's the NVMe media type. It's NVDIMM that's sitting there off of the CPU bus. It's hanging out. So it's just like your current DRAM, your DDR DRAM that you're buying today. Maybe it's DDR4 or whatever you're putting in your servers. The NVDIMM would sit right there off of a similar bus, off a similar DDR bus, and you'd have a slot for it to plug into. The next option is we move down the picture kind of in the middle. This is going to be your NVMe over PCIe. This is what I referred to as a JBOF earlier, just a bunch of flash. So the NVMe media is directly attached to the PCIe bus off of the CPU. So you get bank 0 off the CPU that comes directly out of the PCIe, or it comes to the PCIe bus, and the media is hanging off of it. Now, there are some things that you have to put into place here to make this work, and we'll talk about those in some other slides, but just from a really simplistic perspective, this is kind of how it works. And then the third option is the CPUs that's connected to the drive controller. Again, you're using a SATA or a SAS bus, and then you're going to have the NVMe media sitting there. So that's just your NVMe media sitting behind the SAS or SATA protocol. So these are the options for bringing NVMe into your environment. So let's take just a minute here and talk about the NVMe and why it was designed and what it accomplishes, especially how it's going to displace SATA and SAS. So NVMe protocol from an advantage perspective. SATA devices support 32 commands in a single queue. SAS devices can support up to 256 commands in a single queue. NVMe devices support 64,000 commands per queue and can support up to 64,000 queues. So you can kind of understand here the magnitude that this has increased. So again, think about single threading and multi-threading. Kind of think about how now we've increased the number of lanes that we can send this traffic down. So with a SATA device, we're limited to 32 commands. With a SAS device, we're limited to 256 commands. With an NVMe device, now you can have up to 64,000 commands. So we have increased the performance just immensely here. This protocol is so much deeper when it comes to the queues, and it's a major advancement over SAS and SATA protocols. That's the #1 reason that NVMe is the preferred method moving forward, is because of the ability to be able to have so many more commands per queue and so many more queues. So what does that really do for us, right? Well, the way that it's designed, the queues can now have I/O commands and responses to the commands that are tied to the same processor core. So this can take advantage of what's known as parallel processing. This is a major advancement in multi-core processors. So for multi-core CPUs, they can parallel process. That speeds everything up from the application perspective. And this is a huge benefit by having the commands so that they can operate like this. So due to these massive number of queues, each application or thread has its own independent queue. So as a vendor, when I'm writing software and I'm trying to determine how we're going to handle processing which queues where and when in the priority order, now what I can do is I don't have to lock anything. There's no I/O locking that takes place. So if you've ever had performance issues and you've heard a vendor say, well, we've got an I/O lock algorithm that goes and here's how it stops the I/O here and it starts it there and it's waiting in the queue, that's dead. That's gone. It's not required anymore from that perspective. So it's not going to slow anything down. So the SATA and the SAS commands that were supported, the 32 commands for SATA and the 256 commands for the SAS, they were adequate for hard disk drives. So they could handle that performance because the drive was the gating factor on the back end. But with NVMe technologies, with NVMe flash, this grossly became the bottleneck. So that's the reason for the NVMe storage protocol and why it was designed. All right. Just a quick eye chart here to kind of show you the differences. SATA, SAS, and NVMe, you can see them in the chart on the right. The SATA SSD, it's a single queue with 32 commands. The SAS SSD, a single queue with 256 commands. And then the NVMe, 64,000 queues, 64,000 commands. A major, major difference in technology here. So a lot of people ask us, the #1 question that I field when customers ask us about NVMe and we start talking about their data center is, what about latency? How does it work from a latency perspective? So just a few years ago, 4 years back, 5 years back, everyone was focused on IOPS. IOP was the big discussion factor in data center talk. Anytime you would walk into someone's data center, you'd start talking about IOPS. But that was the wrong focus. the real focus that everyone should have been looking at was latency, and that's what's really came about in the last 18 to 24 months. You know, all of the customers that we engage with and talk to, they're all focused on latency. How do you get my latency down so that my application is going to perform better? So the first thing that I want to note here is if you're using a hybrid array or an all-flash array, or if you've got SSDs in your servers, your latency that you're looking at today is in the milliseconds. You're seeing millisecond latency from anywhere from, 1 millisecond if you have a really quick, snappy environment, up to 10, 20, 30 milliseconds, depending on how that data is being handled. And I'm talking round-trip latency here. From the time that it leaves the server to back down to the storage and back out again, we're talking round-trip latency from top to bottom. With NVMe, we're moving from milliseconds to microseconds. So if you see here in this image on the left, you'll see an HDD SATA SAS interface. It's pushing somewhere around 10,000 microseconds. Obviously, we would have never measured that in microseconds if we were talking just HDDs. But for this depiction, I wanted to put it in microseconds so that you could really comprehend the differences. And as you move to the right on the screen, you'll see SSD, SATA and SAS SSDs. So this would be like an all-flash array today that's not NVMe. It's your standard SATA SAS. It's going to pull somewhere around 106 microseconds. And then as we continue to move to the right, now we've introduced an NVMe SSD. This is your NAND-based NVMe. You can see it reduces to 83 microseconds. And then what's really coming down the pipe that's going to be the future is, if some of you may have already heard of this, the 10% of you that are very well connected to NVMe, you're probably very aware of 3D XPoint. 3D XPoint is going to be the next NVMe SSD technology that is the next big wave. And you can see that the performance here, it moves from 83 microseconds to 13 microseconds. Insanely fast, but also insanely expensive. So this is kind of just a summary of how we've moved as far as technology goes from a media perspective of what the latency will actually do, how it reduces. Just another quick slide on NVMe, the NVMe difference. So NVMe was also optimized. One of the things that the NVMe Express consortium did was they looked at not only NVMe from a media perspective and a protocol perspective, but also as command sets and CPU instructions and how they access I/O and how they process I/O. The NVMe command set uses 50% less CPU instructions to process an I/O request, which is very beneficial for anyone that's having server issues today with CPU issues. This pulls the load down on the CPU. It reduces the load on the CPU tremendously. So it's going to allow for higher ops per CPU instruction and lower latency. They also support MSIX and interrupt steering. This is to prevent CPU bottlenecks, but it also allows you to continue to scale. They support reservations from power management, so you can set power management reservations in your data center. All right, so just a few minutes here we're going to spend on why use NVMe SSDs. First and foremost is the insane performance. You're going to see so much lower latency and you're going to see higher ops. It's going to be better application performance. The PCIe connectivity directly to the CPU, it avoids all of the bottlenecks and the jumps that are there. And then reduce protocol overhead, which is essentially the same as point 2. It's just talking a little bit about a JBOF and how it doesn't have to use iSCSI or fiber channel overhead to connect to the NVMe devices or media. And then another advantage is the NVMe integration points. In the past 10 years ago, if you needed extra performance, you had to go and add it in one specific place. You didn't really have options to mix and match and stick certain things here. You either had to add RAM to your system or you had to add CPU juice, and if you needed more capacity or higher capacity drives for more IOPS and lower latency, you would go stack shelves after shelf after shelf of additional disk under a head. Well, now NVMe changes all of that because a little bit of NVMe goes a long way for some of the customers. So we've got a multitude of different customer types on this call today. I saw there's a lot of enterprises on here. There's a lot of SMBs on here and a mixture in between. So for you SMB customers, you're sitting here wondering, how do I use NVMe and where do I put it? You may only need a little bit of NVMe. It may be in your environment you can survive with just 1 or 2 terabytes of NVMe, and you tier everything else down. And it depends on your infrastructure and obviously what you have in place. But for enterprises, you may need an entire JBOF full of NVMe that's got 64 drives in it, and you need 100 terabytes of this stuff. It just really depends on where you're at. But the good thing is from an integration perspective, it can be as small as 1 drive that's added to a server, all the way up to a JBOF or even a SAN that's completely full of NVMe drives to meet your requirements. So the integration points are really endless there. All right, so the number one question that I get about primary data, when we get on a solutions call, George and his team and I, anytime we're asked by a customer, where should I put my primary data? Here's what I've got today. Here are the problems that I'm having. I'm really struggling with A, B, and C. What do I need to look at? Well, that's a great question. And 10 years ago, you didn't have a whole lot of options. You kind of had DAS, you had NAS, and you had SAN. Those were your basic options, and you had to pick where you were going to live. In today's market, there's a multitude of options in each of the different buckets. So what we try to lead customers down the direction is tell us what you've got, tell us what you need, and we'll tell you what your options are. So we kind of treat it all as a discovery. We don't try to push one specific product, technology, or solution because they don't all fit every customer. They're all different. So, looking at the screen here, an SSD HDD hybrid SAN, that may be the best choice for some of you today. If you're out there and you're still running spinning disk, and you're trying to figure out where do I go next, do I buy another spinning disk array, or do I move to an all-flash array, or do I move to the cloud, maybe a hybrid SAN is a good first step. That gives you a little bit of flash, a lot of HDD, and it allows you to keep your hot data on the SSDs and your cold data on the HDDs. Maybe you've already gone the hybrid route, and now you're looking at additional performance. Do I stack additional hybrid arrays, or do I jump off the all-flash cliff? It simply depends on where you're at from a performance and a price perspective. But maybe you're ready to go down the all-flash array path, and you're looking at SAS and SATA SSDs inside of an all-flash array. Maybe you've got a small environment, and right now it's kind of a cluster, and you need to simplify everything. Maybe hyper-converged is your goal. If you have applications where you can add storage and capacity and performance at the same time, and you can brick it out, hyper-converged could be a good path for you as you grow that out. If you can kind of brick and mortar those things, your clusters, and just continue to add brick by brick as you build out. Maybe it's time to go public cloud. Maybe public cloud is just used for DR, but some people are moving to it for primary storage. Maybe you don't trust public cloud and you want to go private cloud. What about NVMe all-flash? Well, if you need insane performance, yes, NVMe all-flash will absolutely provide that insane performance. If you need faster than NVMe all-flash, maybe you need an NVMe JBOF that hangs directly off of the PCIe bus, and it's got a PCIe switch and RNIC cards connected into your server. But you'd need software-defined storage to manage that Tier 1, Tier 0 storage, and then migrate everything down to slower disk. So there's a multitude of different directions that you could head down, but you need to know what all those directions are, obviously, so that you understand where they go. And NVMe just kind of adds to this. It's another piece that's added on top now because it gives, IT directors, IT managers, not managers, another choice of where do I go. So let's take just a couple seconds here and talk a little bit about the infrastructure options and what we see. This is a very typical common example. I've got 80 VMs, I've got 50 terabytes of storage, and I'm in this traditional IT infrastructure on the left. I've got my switches, I've got my servers, and I've got some amount of storage. It could be 3 different vendors that are sitting here that make up my 50 terabytes. Where do I go? What do I move to? Well, as we just talked, hyperconvergence could be an option. You'd need to stack out the number of nodes you need to put them in the cluster to give you enough capacity to get to the 50 terabytes, and then host those VMs. That's your switches, your server, your storage, and your hypervisor, all in a cute little cluster that allows you to grow it brick by brick. But that may not work for a lot of customers because you need to grow deeper. You need more than 50 terabytes, and it doesn't make sense to continue to add nodes that are giving you performance when you really just need capacity. So hyper-converged isn't for everyone. It's got its benefits, it's got its advantages, and that's another discussion for another day. Another bucket we see people moving into is a hybrid SAN IT infrastructure. So they're moving from the traditional into the hybrid. It allows them to reduce their storage footprint. It allows them to get their hot data on all flash. They keep their cold data on the bottom end spinning disk. It gives them that right mix that they need to operate. This is really good for SMBs that are looking to grow their environment out and continue to add to it where they are not locked in. They can add more flash when they need more flash. They can need more capacity when they need more slow disk capacity. And it gives them that perfect ratio that they need to move their infrastructure forward. And then another bucket is an all-flash SAN. You know, there's customers that they've either gone the hybrid route or they may just skip the hybrid route and they jump directly into the all-flash infrastructure bucket. These are going to be your switches and your servers, and you're going to bring in some type of an all-flash array. It could be a SATA, it could be a SAS, and you may not need a 50-terabyte all-flash array. A lot of vendors, most vendors now that have all-flash arrays, they have a deduplication and a compression technology or engine that runs in their stack, and it allows them to get a 2-to-1, 3-to-1, 4-to-1 on the data savings. And what I mean by that is if you have 50 terabytes of capacity, you might only need 15 to 20 terabytes of actual all-flash space to squeeze that 50 terabytes into. They'll deduplicate the blocks at the block level, they'll compress them down, and they can store a lot more data on that actual physical media. So these are a lot of the examples that we're seeing customers move into that we're talking to at this point in time. So how does NVMe fit into these? Well, again, NVMe is really good because it can go into any of them. It can go into the servers, into the hyper-converged. It can go into the hybrid SAN, into the storage, into the front end of the hybrid SAN. It can go into the all-flash SAN. It can go into the servers and the all-flash SAN. It's really a unique mix that can go anywhere you want it to go. All right, so just a quick level set here. We're going to talk about all-flash hybrid and spinning disk. We had a lot of questions come in for this, so that's the reason this slide's been added in. People were wanting to know what's the difference between a hybrid SAN and an all-flash SAN or hybrid storage and all-flash storage. So we just wanted to throw a quick picture up here. Top right, you'll see a traditional, hard drive type architecture on a SAN. You would have 15K spinning disk on the top, 72K spinning disk on the bottom. There would be some tiering algorithm that would take place between the two. Hot data stays on the faster tier, colder data goes to the lower tier. Now, hybrid storage changed that. Hybrid storage was a mixture of SSDs and HDDs in one box, or it could be two boxes. It could be an all-flash head, and it could be an all-spinning disk, all-hard drive JBOD, the shelf that goes underneath it. But the key there is it's a little bit of SSDs and a whole lot of HDD space. Your hot data is going to be a smaller percentage of your overall functioning data set that you have. So your hot data is stored on the SSDs, the cold data is stored on the HDDs, and the tiering takes place between the two as the data becomes hot or cold. It either demotes or promotes. And then an all-flash storage. This is all SSDs. Different vendors do it different ways. Some vendors only have one tier, some have two, some have three, some have four. It just depends on how they move your data around within their architecture, depending on if they have a hot tier, a cache, a cold tier, or an archive tier, and depending on what they do with it. But it's all SSDs. The hot data and the cold data are stored in the same array. It's just split up between different devices in some cases. Some vendors have just one solid tier, and all your data is on one tier. All right. So we're pressing a little on time, so I'm going to try to speed up just a little bit. We're going to talk about all-flash NVMe storage. This is all SSDs. It's going to be a mixture. It could be a mixture of NVMe with SATA and SAS SSDs. So some of you may only need a handful of NVMe drives to give you the performance that you need, and that could be the hot tier, or it could be a cache tier. Then the cold tier could be your SATA and SAS. So a lot of different vendors carve it up different ways. I would recommend looking at a vendor that can offer these options because, again, no two customers are the same. Your data sets are different. The way you access your data is different. The way you utilize your applications and run your business is different. So make sure you're not getting into a vendor lock where they don't have the flexibility to offer you these different functionalities and the way they can carve their architecture up within that array. Another option would be full NVMe. It's a little pricey right now, but the price is going to come down as NVMe drives become more apparent in the market and as more volume increases. You can do all 24 or 48, depending on the size of the actual box. The SSDs are used for both hot and cache tier space. It can be both cold tier, hot tier. Again, it can be cache. The key here is that the NVMEs can be used to hold the hot data and the cold data, or you could segment it out. It just depends on, again, the vendor architecture and how you want to use it. The key here is there's no IT environment changes required. Your servers and your switches stay. You're just going to change out the storage. You're going to either upgrade the storage or you're going to add in NVMe drives if your storage array is already NVMe ready. All right, the next slide here, NVMe JBOF storage. We get a lot of questions about this. Why JBOF? Well, it's just a bunch of flash. So think of it like it's a JBOD, just a bunch of disk. There's a small controller card in there. There's a backplane. That backplane's connected to all of these NVMe drives. But there's not a controller. There's not an Intel CPU. There's not an x86 controller sitting in this box. So the way that this works is this is attached to a PCIe switch. And that PCIe switch is attached to what's called an RNIC card in your servers. So what it does is it extends the PCIe bus from the server to the PCIe switch, from the PCIe switch to the JBOF, which contains the NVMe media. So this removes the jump that you typically have in a storage array environment where you don't have the iSCSI protocol or the fiber channel protocol. The overhead that's there in those typical storage protocols has been removed. That's the benefit of a JBOF. Now, this JBOF can be completely carved up from top to bottom for your applications. As long as each server is connected to it, each server can be allocated that amount of capacity that it needs from the NVMe JBOF. So if you've got an SQL server that needs 50 gigs, you can carve out 50 gigs. If you've got an Oracle server that needs, 75 gigs, you can carve out 75 gigs and so forth. The key is you have to have software-defined storage to manage it. Either that or you're running the applications on on the specific NVMe instance that carve out, and then you have to worry about backing that data up because it doesn't take care of the redundancy aspect unless you have the software-defined storage. So with software-defined storage, it'll handle the redundancy aspect. It also handles migration of the data. So you could leave your existing storage infrastructure in place that you have today. So a lot of customers ask, who's a candidate for JBOF, for an NVMe JBOF? Well, maybe you have an all-flash storage array, but it's struggling and you ran out of capacity and you need better performance. You would be a good candidate for NVMe JBOF. You could buy a PCIe switch and the RNIC cards, connect it up, and then you use software-defined storage to tier it down. So there's a multitude of different customer fits where the NVMe JBOF would fit. But it does require an IT environment change. You do have to have the RNIC cards installed in the servers, and you do have to connect it to a PCIe switch. All right, just quickly wanted to show the data storage evolution here at StorTrends. 2001, we had a 3400i model. This is our spinning disk array. In 2013, we moved to a hybrid array where we put 4 to 6 SSDs in the front end of the box with 10 to 12 HDDs in the back. That allowed us to move from 4,800 ops per chassis to 100,000 ops per chassis. So a major change for our SMB customer base because now they could get the ops and the lower latency that they needed with the hybrid array. 2015, we moved into an all-flash array with our 2610. That was 24 SSDs. It could be a mixture of SAS or SATAs. We use SSDs that can be configured on the fly, so they can be read-intensive or write-intensive based off of your requirements. We don't lock you into a specific set. We give you the ability to pick what you need based off of your environment. It supported up to 256 terabytes, and it went to a max of 230,000 ops. Now the StorTrends 2620i, this is a product that we're working on today. It's going to be released in Q3. This is a 24-drive SSD. It's an NVMe-based array. It's going to be allowed to be mixed with NVMe, SAS, and SATA. So you could do a mixture if you only need a small amount of NVMe, or you could max it out and put all NVMEs in it. It's a 2U 24 bay. Again, they're configurable. It's up to 256 terabytes, and it's going to have a max limitation of 1 million ops. All right, so real quick, analyze your IT environment, know the truth. One of the things that we see a lot here is customers that come to us and they complain about the previous vendor they were working with. Obviously, they had issues with the vendor. That's the reason they're looking to make a change or a switch away from that brand. A lot of times it's oversold, a lot of times it's undersold. So we just want to tell customers about a buyer beware and kind of let you know what you can do to protect yourself. So example of being oversold, vendor E sells you, an SMB customer an all-flash array. It pushes 300,000 IOPS. That SMB customer only had apps that required 9,000 IOPS. There really wasn't a need for the all-flash array. A hybrid array would have been the most cost-effective route here. The all-flash array vendor was 40% more expensive than their hybrid array offering, but the vendor E rep pushed it with their SE, and they oversold it because they get more commission when they sell a higher priced product. So just be very aware of the oversold model. It exists. It is there. Those sales reps' jobs are to sell you the highest price point object that they could possibly get into your environment. A lot of our customers that come to us, we give them a tool, and we'll explain that tool in a minute. And what it allows them to do is buy other things in their environment. Instead of just spending the entire budget on the storage array, they can upgrade their switches, or they can add more servers, or they can go out and get Veeam licenses and start doing VMware backups, VM-level backups. So there's a lot of things you can do if you have the extra budget there, but be careful of the oversold aspect. Another tactic that's used is an undersold aspect. This is where vendor E sells the SMB customer a hybrid array with 5 terabytes of flash and 40 terabytes of spinning disk. Vendor E underscoped the flash and the H-to-D ratio on purpose, but they did that to get inside of your budget. They knew you had a hard, fast budget set at $40,000, so they sold you a $39,900 hybrid array that has a limited amount of flash in it. So after you've installed it, you start running it, you start running your workloads on it, you start noticing latency, you start noticing performance buildups and bottlenecks. What does vendor E come back and do? They recommend you do a flash upgrade. So you got to get your piggy bank out. You're either going to have to swap your SSDs out for bigger SSDs, or you're going to have to add some type of a shelf that has more SSDs in it. So be careful of the undersold model. Now, we came across these models a couple years ago, about 4 years ago actually, 3.5 years ago, when hybrid first came out. We learned of how this was happening in the market. We developed a tool called StorTrends iData. This is a tool that runs in your infrastructure for 7 days. It's free to run. It's free to use. You can download it off of our website at StorTrends.com. If you just Google StorTrends iData, you'll see 3 or 4 links that pop up in Google. You can click on them and download this tool. It's a simple setup tool. It's non-intrusive, and it's safe. It runs for 7 days, and it runs in the background of your environment. It's going to use the existing performance tools that are in your infrastructure. For Windows, it's going to use your perfmon. For Linux, it's going to use the Linux tools, everything that's already there, and it's just going to monitor the servers and the traffic for those servers and your storage. So it's going to roll up a report that's going to show you your capacity usage. It's going to show you your IOPS. It's going to break down your reads versus your writes. It's going to give you your network utilization and bandwidth. The main thing, though, is it's going to identify your hot and active data versus your cold data. So if you're that customer that has 50 terabytes and you have no idea how much is hot, how much is cold, it's going to come back and tell you you're using, 6 terabytes of your 50s hot, or 8 terabytes of your 50s hot, or you're extremely active and 15 terabytes of your 50 is hot. It's also going to show your system performance. It's going to give you a dedupe and compression ratio algorithm. So it's going to give you a lot of pertinent information that you need to utilize when you start searching these different vendor products and these different technology buckets. So when you're thinking about getting into a new technology, you're thinking about adding NVMe, how much performance do I really need? This is how you know. So use this tool, get an educated understanding of what's going on in your environment, and then you can make a better decision that's going to fit your needs, and it'll avoid you being undersold or oversold by those vendors. Obviously, I have to put a plug in here for AMI. We do support NVMe arrays, or we have an NVMe array on the roadmap. We have all-flash arrays that are SAS, all-flash arrays that are SATA. They can be carved up and configured in any way. We support hybrid arrays. We still ship spinning disk JBODs and spinning disk arrays today to existing customers that have had them for the past 5, 6, 7 years. So we have a multitude of different boxes and options and configurations. If you'd like a price quote on any of those, we have an online price quote generator on our website. If you go to StorTrends.com, there's a green tab on the right that says price quote generator. If you'll click that tab, it's going to take you to a page where it's going to ask you a lot of different values about what you're looking for. It's going to try to size the right box up, and then it'll email you the price quote for that configuration. So if you're interested in looking at what pricing looks like for any of our arrays, feel free to hit the price quote generator. All right, we're going to jump into the demo now. So we're going to go straight into the demo session. I'm going to pull over to the demo page. And I'm going to introduce George Rodriguez. He's one of our senior solutions engineers here in the StorTrends division. He's going to go through the demo with us, and then we'll start answering questions as fast as we can. So George, sorry I went a little long.
That's all right. That just gives me an excuse to tell people to call back in to get a more in-depth demo. So it all works out. So yeah, I'm going to just highlight a few things here from our current all-flash array. Obviously, the NVMe would just kind of build on top of this. But you can see here I've got Chrome open. You log in, no problem, with any web browser. The first thing that you see when you log in is how your capacity is being used, both pre and post dedupe. So you can kind of see, immediately, bam, there's my space savings. And so, but the cool thing that I like to show within the UI is that you can see the performance that your system's pushing. So you can see here currently I'm pushing 140,000 IOPS. I got less than half a millisecond of latency, and there's my throughput. But you can kind of see for the last 2 hours how my system's been performing. And you can hover over these things, and you can see the actual numbers that were being pushed at a particular point in time. But you can also see what's been going on for the last hour over here, so you can kind of get a good feel for how your system is performing at any given point when you log in. These update about every 15 seconds or so. So you always have an up-to-date view of what's going on. The bottom here kind of shows you I/O distribution, so you can kind of see what kind of block sizes are coming in and going out of your system. And obviously your read-write ratio is pretty straightforward there. But one of the other things I like to show, and hopefully it comes up here quickly enough, is the hardware health section. So one of the cool things that we like to do is we like to give you a physical representation of what your system looks like, so that if you're worried about anything physically or you want to know any physical attributes of your system, you can come into the hardware health and you can take a look. I don't know if it'll come up here or not. Looks like it's trying, but basically what it does is it shows you a physical picture of your array. You can hover over it, see different things about your CPUs, your memory, your drives, things like that. So basically your interfaces, anything physically on the unit you can see. Now this page does kind of take a back seat to our I/O. As you can see, I was pushing 140,000 IOPS. So that's probably why it's a little slow here right now. Like I said, one of the other things I like to show is our wizards, so our volume wizard. So one of the things that we like to do for, aside from just checking up on the unit, what you're actually going to be using it for, we try to have as many wizards as possible to make it as easy as possible to implement what you need to do. So for our volume wizard, all you got to do is give the volume a name. I don't know where I'm at on my names, so and then give it a size. I'll do 4 terabytes for this guy. The provisioning, everything's thin. You can choose high or low in this case, so if you want to go into the hot tier or only down in the cold tier. But then you simply hit add to list, and then you can go through the process again for as many volumes as you want to create at any given point. But then you simply hit finish. Everything gets done for you in the background, so by the time this wizard is done, you have a fully functioning LUN ready to plug into your hypervisor or your server or what have you, and you can start accessing the capacity and the performance of the SAN. But I do want to get to a couple questions. So like I said, you can get in contact with us to go more in depth on this demo. So let's go ahead and field some questions.
Yeah, and real quick, I know the demo wasn't very in-depth today, so if you do want to see a more in-depth demo or something a little more personalized, I've listed the link to our Register for a Demo form fill on our website. So if you are interested in looking at a demo, just feel free to click on that, fill out just a little bit of information about, when you're looking to do it and all that kind of good stuff, and we'll get back to you and schedule that demo for you guys. But like I said, that's just in case you guys want to see a more in-depth demonstration.
Yeah, so thanks, Tyler. Thanks, George. Looks like we're really running out of time. We're just going to be able to answer a couple questions. We got a question that came in from Blake. What's the controller failover time, and what are the max capacities for the arrays? So, George, can you jump on that one?
Yeah, so failover is more or less instantaneous. It takes, I think, just a few milliseconds. But the max capacity, we're at 256 terabytes. So.
Yeah, and the reason for that controller failover so quick, we use what we call a virtual IP, a VIP. Yeah. So the hypervisor or anything above it never knows which controller is actually in control. That way we're only in control. We know that. So if controller A does experience some kind of an issue and it fails, controller B has already been mirrored with all the data. So like George said, it's instantaneous. It picks it up. It's already in control. It knows where everything's at, and the I/O just flips over. So there's not even a single timeout from the VM perspective when that failure happens. All right, good question. We got a lot of questions on configuration and pricing. I'm seeing about 8 or 10 questions here that came in on, configuration, pricing, options, throughput options. If you'll just, Tyler will get back with you. We have your name and your information here on the chat, so we will get back with you with answers to those specific questions. We apologize for running out of time. Just one more question here from Timothy. How much faster is NVMe versus traditional flash? For iSCSI, what speeds are you using, 10G, 40G, 100G? George?
Yeah, so NVMe, typically it's going to be potentially hundreds of times faster than traditional flash, simply because of the buses that are being used and everything that Justin spoke to within the presentation. For iSCSI, we use 10G. For NVMe, we would want to use 40 or 100. So.
Yep. All right. Well, again, we thank you very much for your time today.
Let me do a last quick plug, Justin, before you go. We've got a survey at the end of this that you'll be redirected to once you exit out of WebEx. It would mean a lot to us if you've enjoyed the presentation today. Should take less than a minute. If you wouldn't mind just filling that out for us. It's just like I said, it's going to redirect you to a SurveyMonkey. It's like 10 questions or so, all multiple choice. If you guys enjoyed the presentation today, we'd really appreciate it if you wouldn't mind filling it out, just to give us a little bit more information on, your environments, just kind of as we do, more and more, research and development on NVMe would really help us out a lot. So we'd really appreciate that if you guys wouldn't mind.
Yep. All right. Well, Tyler, thank you very much. George, thank you. We appreciate everyone attending today, and we will be following up with those of you that we have your contact information and all of your questions. If you do not get an answer from us, it's probably because we didn't see it on the chat. Just feel free to hit Tyler up, and we'll be glad to get your questions answered. All right. Thank you again for your time, and everyone have a great day.